Okay, again, I'm just working off of the Wave 3 worksheet, and I'm going to write the rules. So every time I see a dot, that's a change in the rule, okay? So I'm going to do, the easiest thing for me to do is to write out what my x values are. So for this one, this starting is when x is less than or equal to, because it's a filled in dot, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I am going to write the rule, but I'm going to write all of the x values first. When x gets to 9, this one's also or equal to, it's greater than or equal to. So when x is greater than or equal to 9, but less than or equal to 4, it's going to follow a different rule. Then when it's greater than or equal to 4 and less than or equal to 0, it's going to follow a different rule. Then when it's greater than or equal to 0 and less than or equal to 5, it's going to follow a different rule. And then when it's greater than 5 or equal to, it's going to follow a different rule. So really I'm going to have 5 rules on here. Now the rule on this first one is simple because it's a constant. So this one is just y equals 2 if x is less than or equal to 9. Then the rule changes. Now it changes to this, which is a line with a slope of 1 because it goes up 1 over 1. So it's going to be x plus, I need to find the y-intercept on here. So it keeps going up 1 over 1, and I'm going to see what that point is. Now, because I can't see it on my graph, the way that I'm actually going to do it is I'm going to do point slope form to solve for it. Point slope form is y minus y1 equals the slope times x minus x1. And I'm going to use this point right here, which is 2, negative 9. So, no, sorry, negative 9, 2. Y minus 2 equals the slope of 1, x minus negative 9. Minus a negative becomes plus. Distribute the 1, so I get y minus 2 equals x plus 9. Add the 2 over, y equals x plus 11. So what that means is my y-intercept on this is 11. So it follows the rule of x plus 11 if I didn't put these as negative. Come on, Lothamer. Negative 9 is less than or equal to x is less than or equal to negative 4. Okay, so now I'm going to go on to the next rule. The next rule is right here. It's just a constant at 1, 2, 3, 4, 5, 6, 7. So f of x equals 7 if negative 4 is less than or equal to x is less than or equal to 0. After that, it's going to have a slope of negative 1, so negative x, and it has a y-intercept of 7, plus 7. After that, it's a constant at 2, and now I just wrote out all of the rules. Do another one. Number 7 down here. Okay. You know what? I'm going to do number 9. It's probably the hardest one. So I'm going to start with my rules. So from right here, this is less than or equal to 1, 2, 3, 4, 5. So negative 5 is less than or equal to x is less than negative 2 because that one's open. And then goes to negative 2 is less than or equal to x is less than, because this one's open, 2. And then 2 is less than or equal to x, because this one's closed, is less than 4, because this one's open. Now I'm going to write my rules. So on this one, it has a slope of negative 1. So negative x, and a y-intercept of 1, 2, 3, 4. So negative x plus 4. If negative 5 is less than or equal to x is less than negative 2. Then it switches to this. Now this is a parabola. So parabolas are in the form f of x equals a x minus h squared plus k. This is vertex form, where you have a vertex of hk. And a is your vertical stretch or compression. So let's look at it. It goes over 1, up 1, so that means that the A value equals 1. It has a vertex of 0, 0, so the HK is 0, 0. And I'm just going to plug that all in here. So I'm going to write my rule as f of x equals 1 times x minus 0 squared plus 0, which just means x squared. When I put x minus 0, that's just x squared, times 1 is just x squared, plus 0 is still just x squared. So that's why it's x squared. What I really did is 1 times x minus 0 squared plus 0. And then I simplified to be that. Now my last rule is a constant. It's a constant at 1, 2, 3, 4, 5, 6. So it equals 6 if. And hopefully that makes more sense to you guys.